Alright, in this video, I like to do sample size calculation for Pearson correlations. And I'm going to compare between Spider, Pythons, and G-Power Analysis 3.1 and Python 3.11. Well, I have already prepared for the codes here for the Pythons, so we just, will be easily to, conduct the comparisons. And what you can see from the Penguin here, this is one of the library from Python. So we can import first. All right, and then here is the parameter. So expected correlation coefficient is 0.3, but actually usually it's based on previous study. But just for this video, we use 0.3 and alpha 0.05 and power 0.8 for the default, And here's is the calculation of sample size, and we're just gonna print it. So I'm gonna just run this one right away. And required sample size is 84.07. Now let's go to G-Power Analysis for comparisons. So this family exact, I'm gonna choose correlation bivariate normal model and priori for the power analysis type. And here I'm gonna use 2 because the first one is gonna use 2 tails. And for the correlation, it's going to be the same 0.3 and then alpha 0.05 and power 0.8. And then we calculate this one. The results is the same, 84. In Python is 84.07 and it will be rounded to be 84, the same with G-Power. Alright. Now let's go to one-sided test. Let's say in our hypothesis that we hypothesize that there is a positive correlation, for example. So we're gonna use one-sided test. So here is the codes. So we're just gonna run this one. All right, so the difference is alternative here is a greater, so it's like greater than 0, all right, for one-sided test. So we're just gonna run this one. Right, so the required sample size here is 66.55. Okay, so it can be 66 or 67. Alright, so let's go to G-Power. So we're just gonna change to one-sided test here, and then everything is the same for the parameters, and then we just click enter, and the result is 67, and Python 66.55. So basically it's almost the same, right? Using Python and G-Power. Okay, so here it is. Thank you very much for watching, guys, and then you can calculate the sample size. You can copy the codes in the descriptions. All right, thank you very much.